Hi, everybody. Welcome to Unlocking the 6 gigahertz band. We've got a great panel here for you today to discuss the global policy, performance, and deployment realities surrounding the opening and use of this band. I'm going to start off with having each of our panelists briefly introducing themselves. So, Martha, I'm going to start with you.
Thanks, Catherine. Hi, everyone. My name is Marta Suarez. I'm the president of Dynamic Spectrum Alliance, and I'm very honored to be here today.
Thank you, Martha. Okay, Rikin.
Catherine, thanks for having me. I'm Rikin Thakker, Chief Technology Officer here at NCTA. We are the principal trade association for the US cable industry, and our members have deployed broadband Wi-Fi at massive scales in the US, and from technology standpoint, that scale gives us very practical view of how spectrum policy translates into real world. So appreciate the opportunity to be part of this discussion today.
Thank you. And then we'll go to Alex and then finally Khushboo.
Okay, thank you very much. My name is Alexander Kuehn. I'm the head of International National Spectrum Management at the German regulatory authority Bundesnetzagentur, or shortly BNetzA, and I'm also the candidate to be the next director of the BR at the ITU.
Hi, everybody. I'm Khushboo Kalyani. I'm from LitePoint. I'm a product manager at LitePoint, which is a subsidiary of Teradyne. We make wireless test solutions for physical layer testing of many different wireless technologies like Wi-Fi, cellular, and a lot more. And then I largely manage the Wi-Fi side of things at the company.
Okay, amazing. Thank you all for those brief intros. Let's get started. So, Martha, my first question is for you. When we talk about unlocking 6 gigahertz, what does that actually mean globally right now? Where is it fully open, partially open, or still contested?
Yes, thanks for the question, Catherine. When we say about unlocking the potential, when we talk about unlocking the potential of the 6 gigahertz band, we mean enabling or creating the regulations for license exempt or unlicensed access. Like every country has their different name for regulations. And there are three different types of use cases. Right now, we have one in the US. We're going to talk about that later. But it's we have applications for very low power, for low power indoors, and for standard power outdoors. And different countries are just adopting the rules to enable devices to operate. And that's broader than Wi-Fi. So Wi-Fi is a great example. It makes it very simple to understand. But there could be other types of devices that connect using these license exempt rules or unlicensed rules. Globally, we had the first decision coming from the US. So that's where it started more than 5 years ago. Then we had other countries that follow with the three use cases with the entire 6 gigahertz band. So that's 5925 to 7125 megahertz. And that's where we had countries like Canada, like, well, I'm thinking, depending on the countries, they had different types of applications. But we had Brazil, Colombia, Peru, Dominican Republic, Argentina, and that's in region 2. So what we call region 2 at the ITU level, the Americas. We also had first adopters in what we call region 1, so Europe, Africa, and Middle East, for example, Saudi Arabia. And then we also had adopters in Asia Pacific, that's called ITU region 3, like, for example, Korea. And then from that initial, like, let's say, big push, we had countries that decided to take different approaches. So some countries decided to open only a portion of the 1200 megahertz band. And that is, for most of the countries, 500 megahertz. That has been the case in Europe. That has been the case, for example, so far for Chile or Mexico. And that's also the case in some other latitudes. And then we have like a third wave, if I may call it that way, of countries that are taking a more flexible approach. And they say, okay, maybe it's not only 500 megahertz, maybe we extend a little bit to make sure that we could have two big channels of 320 megahertz. And then there are countries that are saying, okay, we can, even if that's the priority for Wi-Fi or unlicensed access, why don't we consider a secondary priority access? And we are seeing a lot of colors and flavors there. What is true, and what I could summarize for this introduction, is that the 6 gigahertz band right now has a very broad ecosystem of devices. Because of the first decisions, it has been like a good time, 6 years from there. We have seen many generations, Wi-Fi 6E, Wi-Fi 7, and not only for computers or smartphones. We are also seeing TVs, laptops, of course, access points, routers. So it's really impressive what we have seen in such a short time. And that's what we are seeing. And happy to discuss further. Back to you.
Yeah, thank you for kind of setting all of that up for us as we dive deeper into this. And, Rikin, as Martha mentioned, the US took an early and bold step by opening up the full 6 gigahertz band for unlicensed use. From your perspective, how has that decision translated into real world benefits for consumers and networks? And what lessons does it offer to those other regions as they kind of debate their own 6 gigahertz approach?
Yeah, no, absolutely. Definitely bold decision. Under the first Trump administration, the US made a wise decision to open the entire 6 gigahertz band, and that is full 1200 megahertz for unlicensed use, as Martha mentioned. And this decision has definitely delivered tangible benefits for consumers and networks in a relatively short period of time. So from a technical standpoint, it gave Wi-Fi access to large contiguous block of spectrum, and something that simply was not available in the congested bands like 2.4 and 5 gigahertz that are assigned for Wi-Fi before. And this has directly improved throughput, latency, and definitely reliability for everyday applications such as video conferencing, cloud gaming, telehealth, and of course, remote learning. But worth noting that nearly 90% of the mobile data traffic runs over Wi-Fi today. And in fact, Nokia recently reported that that figure exceeds 90%. So by offloading the majority of the mobile data traffic onto Wi-Fi, even cellular operators are significantly reducing congestion and their infrastructure cost as well on the traditional mobile networks. But there are also clear financial benefits for the consumers as well. Here in America, many households can now save $1,000 or more per year by bundling home gigabit broadband with mobile services. And at the same time, the US leadership in Wi-Fi innovation is projected to generate 1.2 trillion in economic value by 2027. So the Wi-Fi 7, 6 gigahertz, coupled with that, is not just simply a lab experiment anymore, right? We are seeing real world deployment across homes, enterprises, hospitals, campuses, and service providers and equipment vendors. They are able to actually innovate quickly because of the 6 gigahertz rule. They were very clear, predictable, and applied nationwide, right? So I would say that for the countries that are still trying to decide on 6 gigahertz, the US approach definitely demonstrates that unlicensed spectrum can scale responsibly. And the combination of low power rule, the automated frequency coordination, the AFC for standard power, and strong incumbent protections, this all actually show that spectrum policy does not have to be a zero-sum game, right? So I'm glad what Martha mentioned, that number of countries have adopted this and followed the suit that US took actually 6 years ago. Thank you.
Excellent. And so, Alex, if the US has taken a bold approach, I guess it's safe to say that Europe has taken a more cautious approach to 6 gigahertz when compared to the US. What were the biggest considerations driving that decision or that approach?
Yeah, thank you very much for that question. Well, yeah, it was a more cautious approach regarding the possibility how can we use the 6 gigahertz band in total, driven by various factors. One of them is Europe is always demand oriented. We have already opened up other bands for linkage between Wi-Fi for more standard power activities in 5.8 gigahertz. This is already harmonized in Europe before that decision of the US, and the US hasn't got any possibilities in that direction. So therefore, we would like to see how Wi-Fi develops in that direction, and therefore we would like to not make the full band available at this point in time in order to keep it open and keep the pressure of further development of the applications. Then we have already further incumbents, which are different to the ones in the US on that one, and we need to protect them and this is our top priority there as well, in order to define the right framework in order to make the spectrum available for everybody, but with the understanding that all the applications have already then the possibility of regulatory protection as well and regulatory stability. This is then also compared in a situation that Europe has within its cities, sometimes a much higher density of the population in there, and that requires then another approach regarding the spectrum management. And this is then formulated in a more focus on coexistence between different services, therefore the fixed links and satellites and radio astronomy, and therefore we started with 500 megahertz, and then further on now we are discussing the upper 6 gigahertz band in Europe and make this available as well. So therefore, finally, we would come up with a European-wide harmonization decision in due time, and I will come back to that one later on in our discussion. Thank you.
Great. I'm going to take a break from some of the kind of global and policy stuff and ask Khushboo a little bit more kind of about 6 gigahertz on a technical level. So from a test and measurement standpoint, what real-world performance gains does 6 gigahertz deliver?
Some performance gains are pretty obvious, right? Like Wi-Fi 7 took a huge leap in the amount of features it added. So wider spectrum, right? So you see wider bandwidth channels, 320 megahertz channels. So now you have more capacity. They also introduced 4096 QAM. So now you have, with wider channels overall, you get 4096 QAM. You add more speed to it. So there are some theoretical and actually, of course, true performance gains also. But the reality is that the higher the frequency, there is more path loss and propagation loss that these frequencies experience, right? So the reality is that 6 gigahertz signals are not able to penetrate as far like a 5 gigahertz system. So from a test and measurement perspective, you need to make sure that you're testing the physical layer calibration and verification. You're not able to deploy a mesh system just with a 6 gigahertz single access point. You need to have multiple access points. So to be able to realize the gains in reality, you need to be able to use mesh systems, utilize multi-link operation. So to others who said that there is disparate harmonization of like 6 gigahertz globally, disparate availability. To be able to achieve high throughput, you might have to use 6 parts of 6 gigahertz channel in combination with 5 gigahertz and MLO to be able to achieve better throughput. So those are some, I guess, the reality of deployment. Or from a test perspective, also, you need to measure the MLO link, like measure the performance on the 5 gigahertz as well as the 6 gigahertz channel. So there's more test cases that kind of get added from a physical layer perspective.
Okay, excellent. Thank you. And, I know Alex kind of mentioned, he foresees harmonization occurring. Martha, I want to talk to you a little bit about how you expect other countries to kind of continue with this. Do you expect more countries to follow the US unlicensed model, or do you think we're heading towards a more fragmented 6 gigahertz future?
So I would say that every country is considering their particular needs according to their policy. And it's still a very hot topic and trending. Just to give you an example, this morning we had a public hearing, a multi-stakeholders meeting in Nigeria. They just published their draft regulations for the lower 6 gigahertz for very low power and low power indoors devices. Last week, we had also a public hearing in South Africa because ICASA, the regulator, is considering, they already opened the lower part of the band, but now they are considering standard power applications. That's outdoors, and that's important for digital inclusion. And that's happening all the time, right? That's very important. So I would say that what countries are doing now is understanding like how they're projecting their growth, how they're trying to balance the access to the incumbents, because this band is fully used, right? There are microwave links, as it was mentioned, there are satellite applications. In some countries, there are mobile applications, radar. So they need to balance those needs. However, I think what it's becoming very clear is that if there is a decision to open the band or portions of it for license exempt access, users will get immediate benefit. It's not about opening the band and then in 5 years, 10 years, there will be some type of future-proof technology. Here, this is very real. Devices are there. Users are getting more and more. I'm showing my smartphone, but because basically every new device that is coming to the market has a chipset with the entire 6 gigahertz band, and it will be open or not, depending on the local regulations. So I'm seeing, and that's how we understand it. It's like they are balancing their needs. And also, I think that the market is pushing, the users are requesting more and more throughputs, low latency, and so regulators are taking action. That's what we are seeing.
Okay, great. And Alex, what interference risks concern regulators most today? And where do you feel the industry has already proven those risks can be managed?
Well, one of the risks there was, of course, with the fixed links and some of the relation. If you go to an outdoor Wi-Fi environment with standard power, that may create difficulties, and the studies have already proven that this is an issue. I don't see any difficulty from the German perspective regarding the satellite systems in the band, because those can be managed by a good way of controlling the interference situation by the setting of the Wi-Fi environment a little bit away from the satellite dishes. And of course, we have a huge debate between two types of technology here. So a competitiveness between 6G and Wi-Fi technology. From my understanding, and you may remember my sayings a couple of years ago, that both can be combined in a certain way. We had seen a lot of studies that there is a potential risk of interference on both sides. However, I still believe that there are possibilities in a geographical sharing between two types of systems here. We see a share of, for long-term 6G in the upper 6 gigahertz band, but we see here as well, as Martha pointed out, a good way of demand-oriented approach in bringing maybe a second level Wi-Fi equipment in Europe as well to that degree with regards to that potential interference risk. And both types of technology, and in particular 6G, is already on the way to being a more scalable and adaptable system, which is then more stable and could provide characteristics which are much more in favor also to allowing different technologies to work together.
Great. Excellent, thank you. And Rikin, Khushboo told us a little bit about the performance gains from 6 gigahertz, but now that we're seeing Wi-Fi 7 deployments that truly take advantage of 6 gigahertz, can you walk us through maybe what the wider channels and cleaner spectrum enable, not just from a performance, but also like an application standpoint, right? Especially for those latency sensitive and high throughput use cases.
Yeah, no, absolutely. I mean, and as I said, Khushboo touched on that, and Martha also mentioned about low latency. I mean, these are obvious benefits of Wi-Fi 7 and 6 gigahertz, right? The headline capability, which is 320 megahertz channel, that is not simply feasible in legacy band, right? Due to the fragmentation. So that's given, right? So this wider channels allowing multi-gigabit speed, but Wi-Fi 7 is not just about that raw throughput, right? We are talking about multi-link operation. We are talking about improved scheduling, enhanced reliability. All of those parameters are actually adding to it. And these features are actually combined with clean spectrum, the full 6 gigahertz here. They create a platform capable of supporting entirely new use cases, right? We are talking about immersive AR, VR, real-time collaboration and cloud render gaming. And this is not just simply, as I mentioned earlier, not just demo phase or lab experiment, right? I recently came back from the Consumer Electronics Show, CES in Vegas, and I was able to witness actually all this use cases live there, thanks to full 6 gigahertz and thanks to Wi-Fi 7 capabilities, right? The other thing I would quickly mention is that the efficiency is a critical factor, right? Wider channels and improved coordination. It reduces retransmissions for Wi-Fi, lower contentions for sure, and it delivers more predictable performance, right? So that's helpful for dense environments such as apartment buildings, offices, stadiums, etc. And this has become increasingly important as number of connected devices per household is constantly growing, right? And lastly, on this point, looking ahead, we are talking about Wi-Fi 7, but that's not the end of the roadmap, right? Work is already there happening in Wi-Fi 8, and a strong emphasis on reliability, consistency, and ultra low latency rather than just simply peak throughput, right? So in that sense, today's 6 gigahertz decisions are not just simply for Wi-Fi 7, but they are laying the foundation for that next generation of Wi-Fi innovation. In fact, I know this panel is about 6 gigahertz, but as Wi-Fi 8 matures, there is actually a growing case for allocating additional unlicensed spectrum, including in lower 7 gigahertz band.
Thank you so much. And before I turn back to Khushboo for my next question, I do want to reassure the audience we will be talking about the FCC and Ofcom developments towards the end of our conversation. I know those are obvious places to go. We will go there. I think Martha's probably going to start going there in a minute, but we'll make sure to address it. But for now, Khushboo, as these early 6 gigahertz deployments are coming out, what are some of the biggest mistakes you're seeing from a performance and validation perspective?
Like I said in my previous comment, that when the higher you go in frequency, the higher the path loss is, right? And so it is becoming very, very essential to, or from a physical layer perspective, to do basically calibration and verification. Oftentimes we see, not trying to tout LitePoint here, but I'm saying that if you're, so with higher modulation scheme 4096 QAM, the EVM limit has become very, very tight with Wi-Fi 7, right? Which is minus 38 dB, right? And so you need to use equipment which has a better noise floor, which has a better EVM performance, so that it's not adding to the measurement uncertainty. So if the buffer between your device level EVM minus 38 versus your test equipment being minus 42, that isn't enough buffer. And so the odds of you adding the passive component, like basically adding the inaccuracies of your own test rig to the device measurement. So oftentimes that's one of the biggest thing we see customers not able to kind of understand, that there has to be enough 10 to 15 dB buffer when you're doing physical layer measurements for absolute level of calibration and frequency verification. The other challenges mistakes we often see is that many of these devices, because of how disparate the 6 gigahertz spectrum is, there may be devices which have full 6 gigahertz, they may be like just partial. And within that also there are multiple kind of physical layer feature combinations that you need to test. So there are kind of challenges in how you design the test plan to be able to test the preamble puncturing, the multi-RU, all those combinations across different bandwidths and like different radios. So those are a few things we kind of see. The other issue that we see is more around AFC. For standard power access point devices, so standard power APs have to have a certain they need to reallocate if they're using an incumbent or fixed link channel. Also for low power devices, there's a power cap, right? So kind of measuring the correct power spectral density limitations for LPI versus like kind of power for standard point access points. Those are again some kind of mistakes we see customer trying to make, and not being able to understand how to do the validation for an AFC compliant test base. So yeah.
Okay, great. Thank you. So Martha, my question here is asking about how different the policy philosophies behind 6 gigahertz are between the US and Europe. So feel free to start getting into the announcements if you'd like here. I know we haven't formally introduced them, but yeah, so how do their policy philosophies differ, and what does that mean for Wi-Fi scale and innovation long term?
Yeah, the way we see it at the DSA and our members, as you know, they're really global leaders in terms of innovation. We see that a policy or a decision-making process that is opening the band for license XM access is clearly fostering new applications and a wide ecosystem. Because as it was explained before, Wi-Fi can be deployed by SMEs, startups, enterprises, big factories. It has applications for IoT. There are many providers. For example, in the case of the United States, we have wireless internet service providers that are taking advantage of this technology to provide affordable broadband connectivity. Stadiums, like it's a wide ecosystem. So you're attracting investment from different stakeholders and from different entities. What we think that Europe is risky now, if I may say that way, is a long-term competitiveness, because their companies, their enterprises, their users are not getting the same benefits that many other administrations around the world are getting. And of course, there are arguments. They are considering probably the long-term 6G sovereignty or other type of aspects. But as I was mentioning before, there's an opportunity cost. And we also believe as DSA and an industry that it's not putting the two technologies to compete in the same band. There are ideal bands for every technology. And we are convinced that 6 gigahertz is the best technology for WASR lands. And we see that there are many other bands that could be available. Even if they're not now, they could be available in the future for that 6G evolution. And if I may say now also to address your question about what we are seeing in the UK, and I know the public is also interested on that, Ofcom UK came with a proposal that is trying to embrace coexistence and innovation rather than division. Because at the end, the RSPG conclusion is that it was very hard to share, so let's kind of split the band. And we still see in Ofcom's proposal a path forward to say, okay, we can give some priority in the future for 6G applications. Most probably they will be localized users, but then let's keep the door open for license XM access. And they give this opportunity for enterprises to take advantage of a standard power using an automated frequency coordination system. They also extended in their proposal the range. So there are 2 channels of 320 megahertz, and we again think that that's very positive. So still there is a part, there is a decision, there is a part that is coming for a new public consultation. And as an industry, we'll be very happy to support those efforts and to see them materialized in the short term.
Okay. Alex, I was going to ask you about AFC, but we can kind of move that maybe to the end if we have time.
Maybe one sentence at the end of that one. I will directly comment on Martha's approach on that one.
Yeah, I was going to say, if you would like to just comment, go right ahead.
Yeah, that's fine. No, Ofcom made a very interesting move forward, and the RSPG has already addressed that is correct, some kind of band split, but with a priority approach. So we spoke about who is the primary user in what part of the band, and there is still an ongoing discussion if Europe and the European Union is moving into a similar situation like the UK on having 2 320 megahertz channels available, with the point that you may have some kind of natural border with the radio astronomy band in the middle of that one. So that would mean a little bit more spectrum for Wi-Fi with true 320 megahertz channels available, and then allowing them to flourish as well, and having then the possibility for 6G in the more upper part above the radio astronomy channels for 6G. But there is one extension on that one, and that is exactly the same the Ofcom is doing here as well. There is still this, and I said it, the second level usage for Wi-Fi here as well. And at least BNetzA is very keen to keep that option open and look forward to that one, because we see that there is also for some kind of public mobile network operators, smaller cell sizes, and maybe only very dense urban areas, which are very interested in the 6 gigahertz band. So therefore, there's a huge reuse factor, which can be used then later on. And I said it that this is the thing I meant with geographical sharing on that one. And therefore, this additional usage, which Ofcom has addressed in its approach now with more phased approach, is going into the same direction as the German regulatory authority is thinking as well. And we would like to move on that one one in the future too. So maybe we are then a little bit later, but of course we are moving forward in that direction. One sentence to AFC, we see that this is still a technology which could open up a possibility also for outdoor usage. Otherwise, without AFC, we see there is a clear limitation to low power usage, and this is predominantly indoor and will not make any sense. So therefore, we are definitely working on AFC and try to implement it as well. Thank you.
Okay. Appreciate you getting those both in there. So in addition to the Ofcom announcement, right, the FCC is preparing to vote on expanding Wi-Fi use through a new class of devices in the 6 gigahertz band. So Rikin, I want to know your perspective on both of these regulatory steps and what they signal about the future direction of spectrum policy for Wi-Fi.
No, absolutely. So I think since we just talked about Ofcom, let me actually start with that first. How is that proposal? Is it good? It's not as good as what we have in the US, but what is the good part? Well, the good part is that it's not following European Commission's recommendation, right? So see, the proposal came out, and I know it will be ready or finalized in next few months, but it's not following US model, as I said, right? It's not allocating full 6 gigahertz for Wi-Fi. However, it breaks from more restrictive European trend by moving towards an allocation that appreciates the societal value of Wi-Fi fuel, right? So I don't want to go too technical into the proposal itself, but as we know that it actually does the similar split of 160 and 540 megahertz as European Commission has suggested. However, it has allocated that 160 megahertz as Wi-Fi primary, which Martha mentioned actually is a good news for Wi-Fi industry. And it allocates the immediate unlicensed access to mobile access under or with AFC control. Now, more importantly, this does not have the same, in my mind, unreasonable timing conditionality on the outcome of WRC 27 that European Commission actually put, right? So it in fact linked to 7 gigahertz. The ecosystem is not ready for mobile communication for this band, right? Whereas Wi-Fi vendors are ready. They're ready to deliver on 6 gigahertz, right? So in my mind, that entire approach from RSPG is just simply keeping that band aside for few mobile operators and not going to be used for a long time. To your earlier question about FCC, for those who did not follow in last just 2 weeks, what we are seeing that on January 7th, FCC Chairman Brandon Carr, in fact, he was there at the CES, announced that the FCC will consider a 4th report and order that's going to enable the power portable device operations in the 6 gigahertz band. What that means? Well, the vote is going to take place on January 29th, but this is actually creating a new geofence variable power, right? GVP, we call it. It's a new category that reflects a forward-looking approach. Again, a new innovative idea that's going to be adopted by many countries, we hope. This is going to enable high power outdoor 6 gigahertz operation for advanced Wi-Fi devices, right? This is definitely showing FCC's continued commitment to 6 gigahertz for unlicensed, but the industry has also actually reacted very positively because this change is going to unlock capacity and performance that will benefit broad range of use and use cases, right? So together, I would say between what FCC did and this announcement from Ofcom, these developments actually show a clear recognition of innovation and economic values tied with Wi-Fi. I mean, Wi-Fi is going to thrive when regulators provide certainty and scale, and these are good examples to consider for other countries.
Okay, excellent. And I'm gonna now return to an audience question that came in earlier before we kind of started down this path, but now we're here. So, and I think maybe Alex, I'll direct this towards you, but again, anyone can really comment on this. This is kind of providing the background, and then it says Europe's RSPG favoring licensed mobile and upper 6 gigahertz for 6G. What is the most critical policy trade-off Europe must resolve soon? Prioritizing unlicensed for immediate innovation and productivity gains, or licensed for long-term 6G sovereignty? It's kind of it's kind of a big question. I don't know, Alex, if you have any thoughts on that.
Well, as I said already, we should not make any set-asides on that one. So if they have possibilities to make it available, and there is a demand for that, so we see that there is an ongoing use of this lower 6 gigahertz band, and there is more spectrum demand, Europe will definitely react on that one and prioritize further unlicensed. However, this doesn't mean that licensed long-term 6G sovereignty will be set aside on that moment. And just make me here the point for both technologies. The 6 gigahertz band is not the only band below 10 gig or in that area. There are many other mobile bands, and there are still the existing 5 gigahertz and 2.4 gigahertz bands, which are still used by Wi-Fi 2. So if you use them efficiently and have a good reuse factor on the other one, on the other technology in 6 gigahertz, we can make use in the best way of the capacity in that bands. Thank you.
Okay. And Khushboo, I know LitePoint doesn't really have much skin in the game here. They test and validate whatever they have to test and validate. So if you have nothing to add on here, that's totally fine. But I wanted to ask you about the role of RF calibration and verification in ensuring reliable performance in the 6 gigahertz band, and how that testing requirement differs from previous Wi-Fi bands.
So again, going back to my original point, right? Calibration is essential. So effectively, what does calibration do, right? It tunes the device to output the correct power and frequency, like operate at the correct frequency. Those are the two essential things. Now, when you're operating in higher frequencies, it becomes even more important so that you don't interfere with other devices, right? So power and frequency calibration becomes even more essential for devices operating in 6 gigahertz band. From a verification perspective, like I said, like there's a gamut of features that Wi-Fi 7 added, right? So there is just so many more combinations to be tested. Also, many of these Wi-Fi 7 features, for example, 4096 QAM, right? You would technically need a good channel condition or SNR for it, but there is nothing stopping you from using that modulation scheme in probably 5 gigahertz band, right? So there's a lot of different combinations that need to be tested with like all across all the 3 different radios. And if your device, especially with like multi-link operation, you need to validate the transmit and receive performance across different chains, one for the 5 gigahertz radio, one for the 6 gigahertz radio. So there is a bunch of like technicalities and permutation combinations that get added both not just at the chipset characterization level, but also at the manufacturing level. And the other challenge is that some devices may not support 6 gigahertz band, right? So then the manufacturers have to have different test automation not frameworks, but like test flows to validate a certain global SKU that's supporting 6 gigahertz band along with 2.4 and 5, and SKUs which don't support the 6 gigahertz band. So that adds to a little bit of like maintaining different test flow and across manufacturing line.
Great. And Rikin kind of teased this, but I think it's important enough to maybe pull it out as a specific question. Martha, Europe has pushed studies of spectrum above 7.25 gigahertz onto the WRC 27 agenda. How do you interpret that move, or what's your perspective on that?
Well, WRC 27 didn't have any agenda item related to Wasserlands. Somehow the 6 gigahertz topic was heavily discussed in WRC 23. And all of us who were there, we really spent a lot of time and hours on that discussion. So somehow it's kind of, I would say, like strange to bring this discussion again to WRC 27, given the fact that now there is a direct relationship for Europe between the 7-8 gigahertz identification for IMT under agenda item 1.7 and the RSPG recommendation about having an extra 160 megahertz channels in the upper 6 gigahertz band for license XM access. Of course, we understand that every administration has the right to move the way they want, but we don't really see where that direct link is. We would like to see priority for Wasserlands in the lower part of the band, including that channel. If there is a decision and a plan to implement IMT technologies, we want was lands to be protected in the lower part of the band, and we think it would be very hard if there is not a good protection guard band. And well, at the end, the question is for regulators themselves. It's like, okay, if they prioritize IMT in upper 6 gigahertz band, what is their plan then to address future demand for waterlands? And I think that's the question they will have to solve. And now that they're looking forward and planning spectrum needs for 6G in 10 years from now, I think it's also convenient to ask themselves, okay, how we're going to address that growth in the future for waterlands. So again, that's an unfortunate situation, I would say, like mixing these topics again. Well, it seems that we will have a lot of discussions on 6 gigahertz, 7 and 8 in WRC 27. Alex is saying, no, that was
Rikin would like to respond. He gets 1 minute.
No, this is great. I mean, Martha mentioned this, right? Very quickly. So the lower 7 gigahertz, it's the best understood as the natural next step in Wi-Fi evolution, right? From a deployment standpoint, it isn't about speculative future use, right? It's about continuity. And we have seen a recent study where it says 17 to 30 million Americans live in Wi-Fi congested area, right? So without additional spectrum, an additional 54 million, and this is we can share this study to your listeners. Additional 54 million people could face congestion within 5 years, and that's going to threaten the reliability, productivity, and trillions of dollars in economic value, right? So from technical perspective, lower 7 gigahertz offers a natural continuation of 6 gigahertz framework, and that's going to manage this congestion very efficiently.
Okay, perfect. With that, I will let everyone get to the next session. Thank you all so much for your insights, and thank you everyone for tuning in.
Thank you.
Thank you. Bye.